Data drives all of your management decisions on the farm. And now there are more ways than ever to get, create, record your own data for use in your own management decisions. This can range from soil type data, topography data, aerial imagery, drones, sensor data, soil sensor, plant sensors, and of course yield maps and as applied data from throughout the year. At the end of the year, when you're looking at all of this data, it really can seem like data overload. So in this session, we want to look at the different data layers that are out there and then the sources of error that could be present in each one of those layers. All right? Because we want to ensure accuracy in all of the layers we do to make our decisions, our management decisions for the following year. And that's hard to do. All right? It's a lot easier said than done. But we know some of these errors exist. They're well known, but some of them may not be. For example, in a variety plot, even though we may have a well-calibrated yield monitor, when we're comparing all the varieties side by side, most likely each one of those varieties is going to get weighed in some type of weigh wagon or scale cart. Because as the varieties change, kernel size, kernel shape, test weight, moisture can also change. And those can throw off some of the readings that we're recording with even a well-calibrated yield monitor. So that's generally accepted, as there's some error there. So there's things we do like weighing those passes to minimize that error or sort out that error to make management decisions on. But those same things can happen in other plots. In nitrogen plots, especially population plots, fungicide plots, we can also change the shape, size, test weight, moisture content of the kernels that we're recording. And that influences the amount of error that even a well-calibrated yield monitor can have. So weighing different passes in our nitrogen plot rather than just using the yield monitor as our data verification is a good management plan. And sometimes we can have error go both ways. In our low nitrogen rates, maybe our yield monitor overestimates our yield by 2 or 3%. We're still within 3% of the yield, the actual yields, and that's well calibrated. But in our high nitrogen rate, we may be underestimating yield by 2 or 3%. We're still 2 or 3% away from actual. That's a pretty accurate monitor. But now our high to low, we have a 6% spread. 6% on 200 bushel corn, and all of a sudden we're 12 plus bushel difference between those because of the error of the yield monitor itself. That could be a 12 bushel gain from the high nitrogen that's erased because of the error, or it could be a 12 bushel advantage given to one of the treatments because of the error. And that goes a long way when we start looking at the economics of these different treatments. 3% off doesn't seem like a lot, but if we're consistently on all of our low nitrogen passes 3% high, and we're consistently 3% low on all of our high nitrogen passes, there's a bias there that can enter into those results. And we've seen different varieties and how they flex in kernel depth, kernel length, girth of actual ear. The different ways in they flex may lead them to flex more or change kernel characteristics, change more as we go from a low population to a high population. Whereas some varieties with very little flex, the kernel size and shape doesn't change a whole lot from low population to high or low nitrogen to high, and the difference in error in the yield monitor from one end of the spectrum to the other isn't all that much. So the accuracy of the data layers that we use on our farm to make management decisions is paramount. And whether it's our own data that we're using, our neighbors' data that we're using, or a third-party collection company that's collecting that data for us to be able to use, we have to be able to ensure or at least trust the accuracy of the data that's going into each one of those decisions. So we'll look at some other ways that we can verify the accuracy of the data, maybe through multiple data layer sets laid on top of one another to verify authenticity of the data and what we're seeing in that data is actually happening. But our goal in the end is to make sure that our data set that we're going to use to make decisions is accurate and robust to stand the test of time for all of our future management decisions.